I'm here with Liliana Werner. You gave an absolutely super talk on hydrophobic acrylic lenses. Now, let me ask you this. When I put these lenses in, and they're primarily what I put in, when I put them in the eye, the lens looks pristine. You looked at these lenses over time in patients, and you found that they weren't as pristine with respect to light scatter over time. Why is that?
So actually, in our study, you have to understand that the lenses actually they do look pristine. You just see this surface light scattering, or also known as whitening. The Japanese literature called this phenomenon as whitening, but it's actually caused by subsurface nanoglistenings, because these are very small water molecules on the surface of the lens. And the lenses actually under a slit lamp, they do look pristine. It's just at certain angulations during slit lamp examination, you kind of see this whitish discoloration. It's not really a whitening or a whitish discoloration. You just see as white in that particular angle. So during the examination, mostly the lens is actually very pristine.
So these are not glistenings that I would see at the slit lamp, because I see some of these too. These are lenses that at the slit lamp would look relatively clear?
This is actually a very important question, because glistenings, as you know, these are these micro vacuoles which are filled with fluid, and they are distributed inside of the optic of the lens. And the size of the glistenings usually range from 1 micron to 20 microns. It can be a little bit bigger, but usually is that. So these are things that you see inside of the optic of the lens. The subsurface nanoglistenings, they are very, very small. They are measured in nanometers, and they are mostly on the surface. So this is a surface phenomenon. And to the best of my knowledge, all the studies done so far did not show any clinical significance related to these nanoglistenings. But again, at certain angulations during slit lamp examination, you actually see the lens gets this whitish discoloration.
Now, how did you measure these lenses over time?
So in our study, which I presented here, the ESCRS, basically we removed the hydrophobic acrylic lenses from cadaver eyes. So we are not dealing with lenses that needed to be explanted because of nanoglistenings. The lenses were in the cadaver eyes, we removed, and we had information about the postoperative time of these cadaver eyes. And then we could obtain match control. So for each lens, we had a power match control. And in our series, we actually had 49 single-piece lenses, and I think 36 of them were yellow lenses, meaning hydrophobic acrylic lenses with the
blue blocking chromophore.
Exactly, yeah. Exactly. So the way you measure this in vitro is by using Scheimpflug photography. So we have a Scheimpflug device, and the results are expressed in CCT computer-compatible tapes, and this is a measurement of brightness. So it goes from 0 to 255. So 0 is towards black, 255 is towards very white. So you actually have an objective measurement of this brightness. And in the same study, we also measure the light transmittance through the same lenses. And what we observed was very interesting, is that this surface light scattering seems to increase with time for yellow lenses or non-yellow lenses, and towards many years after implantation, the values we obtained were quite high. However, there was no statistically significant difference in light transmittance between the lenses removed from the cadaver eyes and the matched controls. So although you measure the light scattering, it does not seem to affect the light transmittance through the intraocular lenses.
Did the presence of a blue blocking chromophore matter in terms of this scatter?
Apparently not. In both groups, the yellow lenses or the non-yellow lenses, we measure higher surface light scattering with time. But again, the difference in terms of light transmittance with the controls was not statistically significant.
Do I need to worry clinically that patients are having light scatter in lenses that don't have obvious glistenings when or don't have any obvious features when I'm seeing these patients at the slit lamp?
Apparently not, because first of all, we measure here the back scattering, but this is the scattering that is perceived by the ophthalmologist.
By the ophthalmologist, not by the
right?
patient, yeah.
So we are evaluating new techniques where we are going to actually measure the forward scattering. So we have a better idea about what the patient could be experiencing. But all the studies so far, even clinical studies, apparently demonstrate that there is no clinical significance to that. It's just something that you may see during slit lamp examination. So if you put a certain angle of the slit lamp, you would see this appearance of whitish discoloration of the intraocular lens, but not at all angles. Yeah.
Really, really, really neat stuff. Liliana, thank you so much.
Thank you very much again.